Okay, so my name is Darko Filipovski, from Faculty of Computer Science and Engineering in Skopje, the University of Kirill and Method. And together with my colleague Andreja Naumoski, we have been working on a research of analyzing the financial service locations in Kumanovo, North Macedonia. In the next slide, we will see the agenda for today's presentation. I will give a brief introduction on why we did this research, the data acquisition process we did, and the pre-processing we have done on that data, the visualization we have conducted in order to enable spatial data analysis, the results of the analysis, and at the end, I will give a small conclusion. In the introduction, basically in Kumanovo is technologically underdeveloped municipality, so physical access to financial entities is kind of essential. People usually go to their brick and mortars location and don't do online shopping so much or bank transfers. So, but the problem is that they have limited information of what are the services available, which are the firms that are offering these services, so they can't really expand or find better deals. This is one of the things that can help opening a new market potential, as well as researching which of these meaning population clusters don't have access to some of the financial services. The main objective is to collect data for financial entities and to make them available to the citizens of Kumanovo, uncover population clusters which have limited access to financial services, as well as analyze these of access with respect to, for example, parking spaces, because people are more willing to go to that facility if they can leave their vehicle outside nearby. On the data acquisition process, we didn't have much data to work with. The data was obtained from the National Bank of Macedonia, North Macedonia, which has the name and the addresses, but we gathered information for working hours, phone addresses, and so on. We needed to acquire additional information, especially for the analysis process. We gathered information for the roads and some specific points of interest, which we got from OpenStreetMap, as well as population, high resolution population data for which gives us the number of people living within 30-meter grids, which are obtained by machine learning algorithms which are applied over satellite imagery and census information. Since we don't really have census information, and the only one available are from the early 2000s. The data is pre-processed because we were not sure whether it's correct or incorrect, since we know how are the government in the Balkans. So we did a field analysis. We have confirmed the data with the official website of the financial entities, as well as some local location aggregates and so on. Any missing data was replaced to enable easier analysis. To enable the spatial analysis of this data, we must do some kind of visualization. Basically, these entities are some point features, which we symbolized with different symbols, and they don't give us any advantage in the analysis, but they are visually appealing. In this case, we have banks, money transfer services, ATMs, and currency exchange services. In this picture, they are of course enlarged for better presentation, but we are going to work with points for better visualization in the analysis process. When it comes to analysis, the first thing we analyzed is how the population is clustered, because people are the ones that are accessing these financial entities. So being easily accessible gives the advantage to the financial entity. To do this, we use the high resolution population density data and apply the optimized hotspot analysis, which gives us results something like this. The red color depicts significant high clustering of a population. the blue color gives us significant, but the clustering is not, there is no clustering of population, so they are not densely populated areas, and the remaining, the yellowish orangey area is actually not significant. So as we can see, all of these financial entities are kind of like clustered in the center where there is a high density of population, and we can see that northeast and kind of east part of the city are not utilized, so people don't really have easy access to these financial entities. Possibly not, because we don't really know. Maybe it's only a 2-minute drive, 5-minute drive. We don't know the layout. So to elevate this problem, what we want to know is, do all of these population clusters have access to the different financial entities, and how many of the potential customers each of these entities serve? For that purpose, we generated service areas on top of the network of streets, where we modeled turns and established the driving directions without taking into account the elevation. And the service areas are generated for bank branches, currency exchanges, and money transfer services, which are spanning a territory of 1.5, 2.5, and 5 kilometers, while the ATM span with the largest distance of 3.5 kilometers, because usually we as a customer want to access the ATMs much easier than compared to other services such as banks. The service areas can actually be seen here. On the northeast, as the dilemma was happening previously, indeed, those customers in the northeast and the east part of the city are in that 5-kilometer area, so they would need to travel 5 kilometers to the nearest service to finish their errands, as well as some parts of the west and even southwest parts of the city, which indicates that placing some more ATMs or opening new bank branches even in those areas could improve their even living status. They wouldn't need to travel every day, but also they would be more inclined to go to those services, to those firms offering the services, instead of going to the city center, which is exactly what this says. Opening new facilities, especially ATMs in these regions, could increase the number of potential customers. But we didn't answer the question of how many potential customers do these entities serve. So this kind of visualization box plot says a lot of things, but we can see that all of these boxes, especially for banks, are kind of narrow, and they say that there is the bank locations are probably strategically chosen, so they all serve the same customers. But on the ATM side, we can see many dot points extending beyond those boxes, indicating that they are probably outliers and that they are not serving many customers. But that's not actually the case. Most of these points on the ATM side, the number of population that they are serving is quite high, because they are located near high traffic roads. So except one point, which is located near high volume production facility, which is kind of like serving the employees of the firm and not really the citizens of the city. So maybe there's a potential of relocating that ATM to other, potentially in the northeast part of the city. What we also analyzed is the ease of access to the facilities, especially younger generations and the cars we are driving. We want to place them somewhere, park them somewhere. So we analyze the cost of traveling from each of these facilities to the nearest 2 parking lots. This analysis was also done in the similar method to the service area. So they are using the same network of streets and same modeling of turns and driving direction. And this is how the different routes from the financial entities look like to the nearest parking lots. the points are actually facilities, and we can't really see much from this picture. We can see that some lights are kind of exiting of the frame and going outside of the city. That indicates that probably there are some long drives to arrive to a parking lot. So we can really conclude much, but we can see that this box plot being showing on the left side showing the route length, and on the bottom showing the different types of facilities. We can see that banks are kind of like they show a distance, very low distance, except the ATMs, which show a distance of 1.2 kilometers. So but if we look deeper into the results, we can see that actually the facilities are within 500 meters of a parking lot, with most of them being within 100 meters. The outliers being here the ATM with 1.2 kilometers of from a parking facility is because we didn't consider road stops nor private parking spaces, and it is in this case it was a private gas station which has a private parking lot and not available within the data we were working with. So concluding this presentation, what we actually did is centralize the information for financial firms, making them available to the citizens. They want to know what are the services. They want to know when they are working, how they are working, and not really look through or call different institutions to find out about the different services. We provided an overview of what area and population location, what area the facilities can serve, what is the population that they are serving, as well as how they are placed with regards to the parking spaces. We have also shown that some parts of the city are not really well utilized. There can be more facilities placed in that region, especially on the east of the city, where we have seen a increase in population, especially now. Now we have seen a business shifting to that region, so possibly we will see some financial services there, as well as shown how to utilize data generated by machine learning algorithms in cases where they are not available. What would the next steps would be looking into how we can utilize some data from people's movement and how they are moving to so that we can find better locations of facilities, financial facilities, but not only financial facilities, also including other facilities. This data is now more available due to the increased tracking of the COVID cases. So we are looking into that. Thank you. If there are any questions, feel free to ask me or email me at filipovski.outlook. Thank you.
Thank you, Darko. Does anyone have questions? Sotiris?
Yes.
Okay. Hi.
Hi.
Well, we're very glad to see that your topic is somehow similar to ours. Okay, so it is not the port, but it is ATM machines. And yeah, and my question is, are you familiar with service design as a discipline? Okay. And customer journey map, or I mean, how do you define your field?
Actually, no. I'm more into field of computer science, and this has been a project of mine in exploring the software argis. And I have got deeper into that. I have read many papers to fortify my my look on the field, but no, I'm a computer scientist, and I have experience in data science and also in software development and engineering.
Okay, thank you.
No problem. Thank you for the question.
If I may ask, hello, I'm Professor George Papageorgiou from Cyprus. I was wondering if you could also involve the financial service that people get via internet technology in your research.
yeah, the software we are working with can allows exporting of the data in making it available to broader audience. So yeah, I would say so. And it would be easily explorable in sense of it could be interactive.
Yes, but no, the question is more towards the financial services that people get from the banks via the internet. But in your case, that means location is not important anymore. Yes, in that sense.
Yeah, in that sense, we want to say that there are still people that are not covered by the services, especially in this. We are not looking. We don't have the data to look into the specific services each of the entities is giving. So yeah, that data is not really available. We don't have that data. Only the locations and some of the specific in regards to working hour and such.
Okay, thank you.
Thank you for the question.